Talk Show. Recorded live.
Good morning, good afternoon, or good evening, wherever you may be across the nation or around the world. Once again, you're listening to the VMware Community's Roundtable Podcast. This is podcast number 689. My name is Eric Nielsen, and with me, I have my real co-host, Matt Langguth. Today is Wednesday, May 8th, 2024. Matt, how are you doing today?
Eric, is that to say that I am not AI generated?
I was going to put that in my signature file. Like everything you're reading, all the misspellings and everything are classic me. I am not AI generated. Right? It is fair to say it. Matt's good, sir. How are you doing? We're into day 2 for Broadcom. How's things going for you?
Well, Eric, the last time I was on, we had talked about the spin out of what was VMware EUC, right? So VMware EUC being the Horizon Stack, Workspace ONE, and some of our DEX with digital employee experience assets. And with that new company organization, I wasn't able to say the name of the organization at that time, but I am now. And it has just recently launched here within the last week. And the name of that organization will be Omnissa, Omnissa, Omnissa. So very happy to share that and very happy to be part of that EUC organization moving forward. And to that end, we're joined by EUC extraordinaire, Mr. Johan van Amersfoort, VCDX in all things EUC. And we're going to dive into vGPU use cases and how with organizations that have vGPUs deployed for Horizon desktops, how might they be extending out that functionality over to private AI? But before we get into all of that, sir, my favorite questions. How are you doing? How are things out on the West Coast? And what is the color of the bay today?
Well, hey, I'm doing great, Matt, and it is beautiful weather here in California. Nice, cool 70, 75 degree day. We're coming finally into summer. It rained again last weekend. Reservoirs are all full. Mountains are green. California, Silicon Valley is now drying out, and it's sunny and warm. So happy about that. Color of the day is turquoise blue. It's turquoise blue. There's sailfish swimming around. You know, whales are jumping. Just imagine that. Imagine the beautiful California. And then know that I'm lying to you. It is a murky, dark green, muddy bay as it rained last weekend. So we're happy. It is interesting. We are in day 2. A lot of platforms are changing as we move into the post 6-month Broadcom acquisition phase, where we are moving on to a common core infrastructure for Broadcom. Interestingly, some of the platforms are staying as VMware platforms. So Dynamic Signal, which we use for the advocacy platform for vExperts and others, stays on Dynamic Signal. Our blog platforms are still on WordPress. So our RSS stream aggregator for communities and such are still continuing on. But there are other platforms, like our community platform is migrated from Chorus onto a platform called Higher Logic. And that went out this Monday. And as everyone knows, it's always a struggle whenever we migrated from one community platform to another. The great news is Fling are all out now, and if you go to community.broadcom.com, you'll see Flings up on the menu, and they are all directly downloaded. Thank you to Corey Romero for all the hard work he did. You can go get Flings instantaneously, super fast download, all hosted on AWS data services. So across the globe, you can download those Flings super fast, and they're all one-click accessible, all the versions. I think we have now we went from 35 Flings that we were supporting for the last 4 months to 150 Flings, right? So all the old versions are up there. Corey did a nice job of wrapping them all into downloadable zip files that unzip and give you the whole Fling, including documentation and everything in one zip. So really excited about the Flings deployment. The rest of the community platform, I think, as we went on to the Broadcom community platform, the Broadcom community platform had like 7,500 users a day. And as of yesterday, we're seeing 75,000 users a day on the site. So a 10x load. So the CEO of Higher Logic and the CTO of Higher Logic are obviously engaged with the platform. My assessment is it's going to be probably 2 more weeks before everything settles down, which as if Corey remembers, when we went from Jive Forms to Jive, it took us 3 or 4 months to settle it down. The last time we did this in 2016, it took us a couple weeks to settle down. So my guess is it's going to take a couple weeks here to settle down. A lot of your favorite forms are up and running, but the Fusion and Workstation forms aren't coming in till tomorrow. The vSphere and ESX forms are struggling with DB overloads, so those ones are kind of flaky. So we're working through all those issues. I know that downloads, your license portal switched over and they had data breaches. They were connecting things improperly, and therefore they had to freeze all downloads while they work that out. And they're expecting downloads to come back online next Monday, which is problematic for people that are trying to get their bits. So, we are watching the social channels. I'm just being honest on what's actually happening there. It's a huge switch over to new platforms. So everybody's working through it the best they can. So good news is Flings are up and running. Congrats to Corey Romero. We nailed that one. That's the only thing that is working. Reminds me of the Ferrari/Ford Motor Company movie where Matt Damon was like, the only thing that we know, or the brakes are the only thing we know are still working. Everything else is breaking, right? And I would say that Flings are really kicking butt, and some of the forms are doing okay. The rest of it is through that process. So be aware of that and give everybody time. It's going to take a couple of weeks for all of this to unwind itself, which if any of you have been through hard IT projects, you probably are familiar with some of the workings that go on there. That's a long answer, Matt, to what's going on. The call for papers for Explore has closed up. I think we've got 50 or 60 code sessions submitted. We have 100+ community sessions that have been submitted. So we've got funding for the booths. We're excited about that. We're working with the teams. I think at some point, acceptances will go out. We're going to reserve some community sessions for people that submitted sessions that maybe get declined. So we will be offering decline session people that are interesting. We go through all the declines and we look at them and go, oh, this is one. It makes sense that community people would submit to the general sessions first because you get a ticket paid for that. But we will look at declines. We'll also offer some of those. We're excited about all that coming up. Corey Romero, I don't know if there's anything else from a vExpert session you want to chime in on. That's all I've got.
Yeah, I've got a couple things. So I've been working with CTAB, and I've got an opportunity for European vExperts to work with leaders in application networking security divisions at the Europe CTAB, Customer Technical Advisory Board. If you don't know what CTAB is, that's going to be held in Amsterdam in June. The details are going to be going out for that to the vExperts in Europe later today. Future meeting opportunities for CTAB will go out for US later on once I have some details. I also have the VMware events team is looking for vExperts who can create videos for Explore. So I've got an email going out for that as well. So both those emails are going to go out in the next 2 hours. So look forward to those. And the last is make sure you go into the vExpert portal, log in, click events and opportunities, and click the RSVP for Explore 2024 Las Vegas. Yes, you're going. No, you're not. And that's all I've got.
All right, sweet. Well, Matt, I'll pass it back to you, and I'll just say that I know there was a announcement, a new product announcement. We've been waiting for product announcements, and what was announced, I think, on Monday was our AI infrastructure product offerings. And today we're going to be talking about vGPU and use cases for private AI foundations. So take it away, Matt.
Okay. So, Johan, one of the things that we normally do with guests is to ask them a little bit about their background, the 5-minute elevator pitch of who you are, how you got to your current role, and what is your current role within ITQ. So if you wouldn't mind and give us a little bit of background and who is Johan and how you got to where you're at right now.
Absolutely. Well, first of all, thanks for having me. Long-time listener, big fan of the podcast, and first time in the show. So really excited about that. Yeah, I've been working with VMware technologies since probably 2005, 6-ish. Workstation. I think I saw my first VMotion a year later. Started working with VDM back in 2008, 9-ish. And I decided that I like the aspect of talking to end users. That's not common for IT folks.
No, it's not. You're one of the rare
On
birds.
average, we want to sit in our bunker and just fix stuff and build awesome stuff and not talk to end users. But I like that aspect of IT, so I decided to make a profession out of it. And last 1st of May was my 10-year anniversary at ITQ. So 10 years ago, I decided to move over to ITQ to specialize on end-user computing, VMware End-User Computing. At ITQ, I got the opportunity to build a team to do that, and I would say that the team that has an EUC focus nowadays is roughly between 65 and 70 people. And we do everything Omnissa nowadays EUC. So it's Horizon, Workspace ONE, all automation stuff in it. We do dropship provisioning. We build Horizon environments for large, like extremely large enterprises. Biggest customer, probably roughly 150,000 end users. And it has been, really awesome working with a huge team of passionate people. I was probably consultant number 7 or 8, and we're a little over 230 right now, in 5 different countries, 7 different offices, and and this year I switched roles. So I had an EUC focus, and kind of did a lot of AI stuff as a side hustle. But since the beginning of this year, I have a new role. I'm chief evangelist in our CTO office at ITQ, where I have a part focus on R&D and talk to customers to see how we can create value with the solutions that Broadcom and Omnissa are building. And we'd like to see what cutting edge technology we could use to not only create that value, but also use the solutions that we built and create managed services out of it. And that's also part of my job. So I kind of talk to customers, listen to what's happening there, looking at trends in the market, and take those learnings with me and see how we can create services out of that. So and part of those one of those R&D projects currently is what we call Project Einstein, and that's probably going to be the topic that we're going to talk about a lot, because if you want to talk the talk, you need to walk the walk, or the other way around. I always forget that. But what we did is, when looking at ITQ's business processes 10 years ago, it was fairly straightforward. I knew all of my colleagues. I knew the name of their wives or of their spouses. I knew the names of their kids. I knew what they're doing, where they were doing it. And that was really awesome from a family/culture perspective. But with 230 people, that's quite challenging. But aggregating knowledge and knowing, if a customer calls, I have a problem with NSX, and I need to do microsegmentation in this type of industry, then 7, 8 years ago, I knew who to call and what questions to ask. Nowadays, that's quite challenging. And next to that, it's also because the complexity of the solutions have increased. We're seeing that both building, deploying, and managing those infrastructures are complex as well. So we decided to use one of those platforms, the platform we're talking about today, Private AI Foundation, to build our own llama-based model, train it with our own documentation, with a lot of the online documentation that's available on the VMware site, and build different types of solutions out of it. A chatbot we can use to ask questions about, well, I need to upgrade from vSphere 7 to 8, and I have this type of hardware. What should I do? Or I need to create an offer for this type of customer with this type of solution. What steps do I need to take? So it's basically, the private AI version of ChatGPT, but massively trained on our own documentation, and it's an insane R&D project.
Let's walk through a little bit. So I'm assuming that this is in production, if you will, within ITQ. That this isn't just
when is it in
POC
production,
at this
right?
point?
So we build it. We build it also to get the idea of how to build it in production at a customer as well. So we completely designed it. We build it based on the production requirements from Broadcom. So it's running on VCF. We have multiple nodes with multiple GPUs. So we can actually pull the plug of one of the nodes, and it'll because it's microservices based. It still continues. It is fully highly available. It runs based on the Llama models you would use as an enterprise as well. So it's fully enterprise based. Coming back to your question, is it running in production? Well, when is something like this in production? So it's a dog fooding or a champagne drinking environment where we are constantly improving the environment. We're constantly tweaking the model at the back end or the answers that it's giving. We're also building some added value services that we think are valuable to customers as well, like an API gateway or a different front end or Teams or Slack integration. And that's also kind of part of that R&D project. So it's in an R&D phase, but it does. We do run production on it.
So walk us through what, for listeners out there that might be not familiar with Private AI Foundation, and how this looks from an architectural overview. Is there the equivalent of pod and block, if you will? Is there a management domain and a workload domain, like I would think with Horizon? How is this deployed, or how do you have it deployed currently to build off of this language model that you have out there now that you're feeding into it?
Yeah, so we completely follow the architecture and white paper that have been created by Chris Wolf and his team. It was announced at Explore last year in the US. And if you look at how it works, it's basically, you build a VCF workload domain. And from VCF, you can spin up a Tanzu instance. So we run Tanzu as a Kubernetes layer on top of that, and that's already like the base that you need to have. Tanzu is integrated using the GPU operator from NVIDIA because it's really important to be able to integrate those GPUs into the container workloads that you can run on top of that. So that's basically the base infrastructure. We have VCF with all of the components, so NSX, vSAN. We have ARIA operations running. Lifecycle manager is there. So basically, the infrastructure as you would build it as an administrator as well in your own environment. Then again, on top of that is the Tanzu platform to be able to run the workloads, and the workloads there is that's when it becomes interesting, because there are many different ways of how you would be able to run a model in your environment. The thing, first of all, that you need obviously is a GPU.
And let's pause there, right?
Yeah.
Again, for someone that's looking this from the outside, why is it that GPUs are so essential to private AI, and why they are so much more efficient as opposed to traditional CPU workloads?
Yeah, that's a really
What
good
is
question.
it about a GPU's structure?
Right. If you look at the difference between a CPU, modern CPU, and a modern GPU, is a CPU is really good at
The-
serial
That
computation.
really
Am I still here?
You're still here. I think
Yes.
Matt has
Okay.
slowed
Yeah.
down.
Right. So if you look at the difference between a CPU and a GPU, is a CPU is capable with a few cores of handling any type of calculation. So it's those cores are extremely complex, and they can handle a certain amount or a certain number of calculations at the same time, but it's not built for parallel processing. If you take a modern GPU package, an average GPU could easily have thousands and thousands of cores that are good at parallel processing, but those cores are not complex. They can handle a specific type of calculation really, really well, and give an answer back really fast. And because they're in such a large number on a GPU package, you can send a ton of calculations at the same time and get a really fast answer of all of those individual calculations back. So we call that matrix computations. And this is where it becomes very interesting, because if you look at how NVIDIA was able, and by heart, I think somewhere in the mid 2000s, they developed the first version of what we nowadays know as CUDA, the CUDA API. CUDA basically is an API that lets you send calculations to a device that was originally built to do graphical calculations. And CUDA has become the de facto standard when it comes to matrix computations and being able to send those calculations, so the computational calculations, to a GPU, that API. So there are different other ones like OpenCL, but they're not that quite commonly known or used. So CUDA is the de facto standard there. So NVIDIA built a framework of different solutions on top of that, that basically have created an ecosystem of solutions for deep learning, for machine learning, for computer vision, for all sorts of use cases that can heavily benefit from those matrix computations. And two of the most commonly known frameworks for deep learning are TensorFlow and PyTorch. So if you look at what the added value of the platform is, I have worked with a customer in 2017, 16, 17, to build an environment for data science. So they had a large team of data scientists, and those data scientists wanted to run their computations on a vSphere platform. The NGC platform of NVIDIA, so the NVIDIA Graphics Cloud Platform, was not available yet, or it was in beta. So we basically needed to build the entire environment ourselves, which means that you start with spinning up a VM. You install Ubuntu or any form of Linux on it. Install some base tools to compile and to be able to install the GPU driver from NVIDIA. Then you start installing Python and TensorFlow and the CUDA deep neural network, and a ton of different frameworks on top of that before you can actually start your application or test a script. And we found out that building such an environment at scale is extremely hard. It happened a couple of times that we built a VM 3 times in a row in the exact same way with the exact same tools and frameworks in the exact same sequence, and we had a different outcome with all 3 of them. So
even using a CI/CD build process, some type of
100%.
Terraform or other type of tooling set, even though that you're doing a prescriptive non-click to run installation package, you're still ending up with 3 separate results because of the complexity of how things need layered in and what's grabbed when and timing and on what host I'm sure that the VM's running on.
Yeah, and if you eventually we built something for the customer that worked after 3 weeks of voodoo almost, and then what happens? You have something that works, the customer is satisfied, but then something needs to be updated. Some part of any of the frameworks need to be updated, like a new TensorFlow version or a new CUDN version or a new NVIDIA driver version, and then the whole.
I feel like this is analogous to
what
we would do with a Windows 10 build process if we were trying to package everything into the base golden master, right? Where we weren't pulling it out and sticking some apps and apps volumes for those EUC friends that are listening along.
Yeah, well, it's it looks quite similar. Now, NVIDIA in 2017 created the NGC platform, the NVIDIA GPU Cloud, and that basically is a repository of complete Docker images that contain all of the individual frameworks, the CUDA drivers, or the CUDA deep neural network frameworks and drivers and stuff. Everything is in there. So you basically pull the Docker container, run it on your environment, and the only thing you need to do is inject your script, for instance, and you're done. You can actually run, and it's that simple. But and this is that was, let's say, 2018. Now, if you do that at scale, you need something to manage those containers. You need a container repository. You need configuration management to be in place. You need your CI/CD pipelining tools to be in place. You need your platform engineering tools to be able not just to build it, to maintain it at scale, to secure it, to do everything. And this is where the Private AI Foundation platform is it's just awesome. We've been hoping for something like this a couple of years ago to arise, and when it was announced during Explore, we couldn't be happier, because this is what we see is the common challenge at customers. You can build it, but then you need to maintain it. And what happens if something needs to be updated, or if you need to secure it, or today you're working with a version of a Llama model, and tomorrow you want to replace that model with something else, because Meta is not sitting still. They're constantly improving the models as well. So you need a platform and a solution to be able to replace that model in an instant. You need to be able to secure the individual vector databases also in an instant. You need to be able to do all of that, and this is where the Private AI Foundation platform is the go-to platform. Now, I have a question to you guys as well. Do you use OpenAI's ChatGPT?
I have, yes. I as soon as I can remember actually messaging Eric in the background, and this would have been Christmas time or around 2022 going into 2023, and it was one of those what I call VMotion-esque type events. It was, once you saw it, it was like, holy cow, this is going to be a thing. And it's just exploded from there.
So have you ever fed something into ChatGPT, like a PDF document or a ton of information, and you want to have a recommendation on, or you have a certain prompt, like could you create an abstract, for instance, out of this text? Have you ever done something like that?
Yes. Now, one of the first things I can remember when you would feed information to it, it was limited on its data set. So based on the nature of the query, especially if you asked it something like with future events, or that it needed to grab a current stock price for an item, or you were trying to do some type of, let's call it relevant current day information, it was limited, again, on at least on the initial deployments, of what the data set it was initially trained on.
Yeah. Well, I think this is one of the. I think it's good you be able to do something like that, but we did a couple of experiments with ChatGPT. So I have a colleague, Martijn, who leads our cloud native initiatives as a VP, and he is within our company. It's kind of a running gag. He has a certain Dutch quote he said a couple of times. So with a couple of colleagues and other familiar people within our network, we fed that quote together with his name into ChatGPT. So we mentioned to ChatGPT that he is commonly known about that quote, and now ChatGPT took that over. So ChatGPT now knows Martijn van Tol about that quote, and now it's just it's a running gag. It's fun. It's but what happens if you feed your company information into it and you do it a couple of times? You don't know what happens to that data. You don't know if it's going to be used for answers of other people. And the question is, if do you want to put all of your eggs in that basket as a company? Another example of that is Bard. Bard by itself, when it was first announced, it was a really good competitor to ChatGPT, but it was trained, and this is kind of like, I think, good. It was trained with diversity and inclusion in mind. And I think it's really, really good if the answers you get from such a platform are inclusive, are diverse, are ethnic diverse. So what happened is someone, and this is just like a single moment, someone asked a question to Bard, like, could you create pictures of Vikings? And what it did, you saw like 4 different pictures of Vikings with an Asian, how do you say it? Like Asian roots, or with African roots. And
sure,
yeah, and that's just how such a platform is trained. But it was the beginning of the end for Bard, and this, I think, by itself is all problematic when you use those platforms for your enterprise. I think this is one of the, together with the security aspect of it, is one of the reasons why customers and companies should consider running those platforms on-prem. And this is where Private AI Foundation, powered by NVIDIA, is the go-to platform.
So to expand on your example, how would you, in this model, or how have you to date, corrected some of the assumptions that it has generated based on the data that you had fed it? Where is the course control, if you will, and how is that implemented?
Yeah, so this is, I think, a terrific question. So what we did is we brought, so it's running in what we call our experience lab. And what we did in the last couple of months, and June 6th, by heart is the next one, is we're traveling around to all the user cons in Europe. And we brought the front end of the platform, Project Einstein, to the trade show. So we have a big roll-up banner, says, ask anything you want about VMware solutions here. Well, our new virtual consultant will answer those questions. So what we did is all of the questions and answers given, I took them back and analyzed them. So you can, we call that reinforced learning. So you basically can give a thumbs up or a thumbs down to the answers giving. And sometimes the answers are spot on. But what we saw, for instance, is if you train the model with information about vSphere 6, 7, and 8, and you ask a certain question without specifying the version of vSphere, you might get a different answer back, correlating to a different version than the question you were referring to. So at the back, we're tweaking those answers, and
You almost have to train it as a consultant. It sounds like you have to train it to ask clarifying questions.
Dude, I have 2 little kids of 2 and 5, and it feels like that all over again. But yeah, this is how you improve the response of the RAG application, and it's very fun because we can at the UseCon in the Netherlands, we already had roughly around 120 questions. Most of them were answered correctly, but some we had already we made some improvements. We took it to Germany as well. Same happened a little bit, and we're now hoping for Belgium in a couple of weeks that most of the answers will be spot on. And this is also, I think, part of that dogfooding process, right? So we're internally using it to create offers and to create answers, or to ask answers for specific customer related questions, and most of those are very well responded. But also you need to be aware, and this is a little bit of education, right? So prompt engineering is really important as well. Sometimes the prompt is just not specified that well, and then you get an answer that you weren't hoping for. But yeah, this is also something that we're working on. So there's a little bit of education coming into that as well.
So educate us, if you will, a little bit, and this is where my knowledge of it, frankly, falls off, is the initial workload as far as, taking advantage of the CUDA API at the time of ingestion of the data set, right, where it's most intense on the GPUs, or is it constantly processing? In other words, I think of it, okay, we're going to load the data set in it. It's going to munch through the data, and it's going to have some pre-canned answers. And then it's just going to need like a couple little polls, like when we're actually querying against the DB. Or is it just pounding those GPUs from the time, not only on the data set analysis, but then the queries as well?
So short answer, yes, to the last one. A little bit longer answer. So NVIDIA created a framework for conversational AI. They call it Nemo. And during the last GTC conference, they announced something they call the Nemo. A NIM, Nemo something microservices. So it's what it is a complete solution containing multiple different microservices, like a inference server. Second thing is, for instance, a vector database. There's a front end. There's a solution that you could use to feed PDFs or other forms of information into it. Now, if you take those individual components, one thing, for instance, that's always running inside the GPU memory is the inference server with the model. So the inference server contains the actual model that you download. And the reason why it's running inside the GPU memory is because every single query you send to the model needs to be replied as fast as possible. If you would send a question, you would send a prompt, and you get an answer back in 2 or 3 minutes from that moment, no one's going to use the application. So this is why a GPU is really valuable. And what you need to know about such a model, like a Llama 13B model, contains 13 billion parameters. And every single parameter is roughly 2 bytes in size. So that's already 26 gigs of size that you put in frame buffer. Next to that, the vector database is the database that contains all of the documentation, all of the additional information that you feed into your application. So I have a model, Llama 13B, and what that does is, in this case, it knows natural language. It knows, based on prediction, what kind of word would probably follow after another word if the context in the prompt is taken into account. Now, feeding my own documentation, in this case my ITQ documentation, into that model means that I need to have something which we call a vector database that stores all of the information that I want to ask questions about. So then I have the model, I have the vector database that runs inside the GPU memory as well. Now I need an additional process that's basically capable of analyzing the documents I feed into it. So taking a PDF, an average PDF, I fed my own books into it. One of the books, like the first version, is roughly 26 megs in size. What I don't want is, if I feed that PDF into the application, that it takes another 30 minutes before it's completely processed. So this is also what happens in GPU memory. It's loaded in memory, it's being parallel processed, and it takes roughly 10 to 20 seconds before the entire book is read and put into the vector database. Another process that runs on the GPU. And if you scale it out, because you want that application not to be tied to single components, one is none, you want it to be highly available. That means that you need additional GPUs that contain multiple of those models, that contain multiple of those vector databases. You're not using a single vector database, because look at law enforcement. We're working with a customer that has confidential data. So they have strict confidential data, highly classified. There's something in the middle. Then there's something that's lightly or mildly classified, and there you have public data. You cannot put all of that data into a single vector database, because there's no RBAC system. There's no way of classifying confidentiality.
It was all in one single vector database. It's going to produce classified, mid-cat classified, and public information.
Correct. So you might have multiple vector databases that run in memory as well. So this is why a GPU platform is essential.
So I want to switch gears, Matt. I know you have a hard stop, and Johan, I know that we got started a little bit early, so maybe we can grab another 10 minutes for your time, because it looks like you're somewhere at the end of your day. I was over at the Colorado VMUG, and Justin Murray works at VMware, and he's been in AI for a while, and he actually brought up an interesting point. We apparently took the vSphere code base, right, and we ran it through an AI engine, right, and then we asked it to build some features into vSphere, right, and it did. It wrote really decent code. Another friend of mine is saying that what he sees a big trend, and almost like a Web 3.0 kind of moment, is the idea that as an enterprise, you can start feeding your code bases into an AI, right? And then you can actually just ask it to build me a new feature, right? And that he sees, because he's a programmer, right? He sees this coming into being, where it's going to accelerate enterprise application development and builds, because the cost of entry to get a new feature and to get a new application is going to just drop down to nothing, because your AI will just be able to build you what you need. I'm just wondering what your perspective of that scenario is.
So I couldn't be more excited, and especially for the next thing. So Sean Bass is extremely famous for his quote about traditional applications, cockroaches, and Twinkies, because what he said is, after nuclear war, there are just three things left: cockroaches, Twinkies, and traditional Windows apps. What if, and I had a conversation with a customer a couple of weeks ago about this. They were replatforming all of the traditional apps into something modern, but it was an extremely costly process. like you mentioned, what if your code generators are on such a level, maybe in a year from now or 2 years from now, that they could completely rewrite all of your traditional apps into modern microservices-based cloud-native applications? That would solve like a ton of issues that we currently have in the
being
infrastructure.
pinned in legacy apps, right? Where we hear this story all the time. Well, it's legacy, and we got 1 million man hours to write it. If you could train an AI just to break this up efficiently and make it microservices and run it under Kubernetes and build that infrastructure, even if it took a week or 3 or 5 weeks, you would be able to free up a lot of resources because you could do that. And that's what he's saying, that it's the cost of new applications, whether it be converting old ones or just asking for new ones, is just it's gonna actually come to be. That was his prediction. So yeah, interesting.
Yeah, and the question now is like, should you as a customer invest money into replatforming apps, or should you just wait 2 or 3 years and hopefully everything will happen automatically? And like I'm a big fan of VDI. Everyone probably knows me about the fact that I love VDI. But what happens if like overnight all of those apps could be generated from a really great AI platform, and as a result, we don't need VDI anymore? That would be like
VDI was
kind of a
always
dream
about the
scenario.
apps anyway, right? It's just a means
was.
to get to the apps.
Right. And then
Means the
when you
OS.
start thinking about, what kind of platform do you want to have in place to write your apps, right? Well, that's an internal, that's probably something you want internally running on kind of a vSphere implementation, right? Like, so that you can manage it, because this is going to be extremely critical to your business, right? Like this is, and to your point of data sets, right? What if all of your knowledge of your apps are big data sets that are then generating new apps? If you lose control of that, or that gets out in the public domain or to your competitors, you've just got a big problem, right? Because they can see
Yeah.
exactly what you're doing, right? And they could run an AI on your code base to figure out where you're going to go next, right? And it's just right.
Friends, I hate to interrupt, but Johan, thank you. I need to jet off here to another customer call. We'll let the conversation continue along. We appreciate you being here as always, and we'll catch up shortly.
Absolutely. Thanks, buddy. Talk soon.
Thanks. And Johan, we've been live streaming for 47 minutes. We usually go to 55 minutes and then do a barbecue report. So I got you for 6 more minutes to talk theoretical long-term implications of this. But it is true, like you got TensorFlow and you got a couple others. Are they, are you going to have an industry consolidation where we'll get to 1 or 2, platforms, models that you're going to run in your enterprise?
Well, that's a great question. I have no answer. So what we're seeing in the cloud native world. So if you take away AI is a great use case to run on top of cloud native, but look at the CNCF landscape. So the cloud native computing foundation landscape.
Right.
There probably, if you look at observability, for instance, there are a ton of different solutions that do the same thing or are slightly different, but there's no de facto standard when it comes to observability. The same with Kubernetes. There are tons of really good commercial offerings of Kubernetes. Tanzu is a great one. OpenShift is there. We got Rancher, but there's also tons of really good open source versions. So Kubernetes is a thing. We know that, but how to do it, how to manage it, that's already a challenge by itself. So there's when you take the abstraction level of AI on top of that, it makes it even more complex. We know that CUDA is the de facto standard when it comes to API calls, computational API calls. We know that Intel is doing a really good job with their GPUs, but they're not there yet. AMD, same thing. And there are a couple of tiny companies that build specific accelerators for AI as well. But
right.
NVIDIA has won the game. So
all right, so I got one because you hit me on another thought process. So Hock Tan is actually now our CEO of Broadcom, is now on the Facebook board. right? And I'm like, Facebook board, why is he on the Facebook board? Well, it turns out the reason he got invited on the Facebook board is that they want to build application specific AI chips, so that you have chipsets in silicon that are specific to a given AI workload, right? And so that they're actually, now the industry is looking at like, well, we're just not going to use a generic GPU from Intel or NVIDIA now we're going to actually ask the chip vendors to start building AI chips for per specific application. And that gets back into coding, AI generated code, AI chips to run the AI generated code. And it's just like, it's moving so fast. It's like the internet days, right? Where nobody's settled out yet, but the technologists are running fast, right? Like, and then how do customers get a hold of all of this, right? Or do they just pick something and like and I don't know. I know that Andy Murray is looking at it from a chat bot. He implemented a chat bot that apparently is popular in Asia that uses the VMware stack to be able to do this, just as an example app, but they're actually selling it. And it's fascinating that in Silicon Valley we hear things like application specific AI chipsets for AI, and then it depends on who you talk to, where you think it's going. You're talking to customers. You're probably just talking about traditional, learning, imaging, AI, just what you're talking about, grabbing the company text-based and putting it into a model. Where do you think it's going to be a couple of years from now with regard to enterprise consuming this stuff?
Great question. So what we're currently seeing is that what we have been seeing in the last couple of years is that there's not a lot of variety when it comes to accelerators. So there's GPUs. There's a new GPU model every year from NVIDIA, or a couple of them. But if you look at the type of workloads or the type of AI-related use cases, if you take from development to production, there's training workloads, there's validating the stuff that you trained, there's actually building the model itself, or a model, to all the way to production, where you have an inference-based workload that just validates or gets API calls from an application, find this or this. What we used to do is run everything on the same GPU, the same powerful GPU or the same powerful GPU cluster. And what we're now seeing is, for instance, the Intel Sapphire Rapids and Emerald Rapids architecture have a chiplet, or have a part of a chiplet inside the socket that's good at parallel processing, does matrix computations. It's not extremely powerful like the Blackwell architecture from NVIDIA is, but it does something really good. So look at the inference type, or the inference part of the workload that can run perfectly fine on such a CPU, and that's more power efficient, is less costly. Right. So I think what we're going to see is that there's going to be a distinction between the different types of AI-related workloads and phases within your AI development within organizations. And maybe some of those workloads will be offloaded to data centers, to big hyperscalers. Could be.
Yeah, I can see also. You mentioned power consumption too, right? And separating the workloads into micro bits that then are power efficient, because GPUs are not power efficient, right? They're not heat efficient. And if you start pushing some of these AI workload where the data is collecting out on the edge, then you really do want to have, low power consumed application specific chips that can deal with the real-time nature of the data collection, whether it's an automobile or a train or some other on a telephone pole, that could get you what you needed from that data set out on the edge with using a low power consumption model, right? So I could see that.
Yeah, and I'm doing that at a really small scale at my home as well. So I build an application that does object recognition inside my security cameras. So it opens up the RTSP stream, and I trained a model just on detecting my cat, just for for the sake of fun and learning about the technology. If I run that on a powerful GPU, like an RTX based GPU, I do roughly around 60 to 100 frames of object recognition a second. That's not really, well, it's cool, but is it that valuable? I run the same application on a Jetson Nano with 4 gigs of RAM and a tiny GPU in it, and it does 4 frames a second, which honestly is perfectly fine. So what I'm now doing is building, and that's really cool, based on the NUC, the Maxtang NUC that we got as a vExpert gift. I built a K3S cluster with that as a controller node and 2 Jetson Nanos to create a microservices-based object recognition application inside my home. And this is where I think it becomes very interesting, because it's low power consumption. It's based, or it's tailored to my use case, and I think this is also something that we're going to see in the future as well. We will be able to run models on low powered devices in the future.
Right.
We're talking about low LLDs, large language models, but there's already a trend going on to run small language models, SLDs. Gemini and Gemma Gemma is an example of that. It's 4 gigs. It's a lot smaller, and we'll see improvements from that regard in the future. So, yeah, it's very exciting.
I really question myself, like, how big a chip would I need to simulate Johan? Right? Like, do I really need a big? Can I just do it in a small chip with a 12-volt battery? Right? Like, how much would I need to replicate this entire interview that we did? Right? Like, I'm like, I don't know.
Yeah.
Right? Like, especially if you just have the data set of everything in your brain. Right? Like, it's not that big. Right. So you can have workloads that are very specific to a smaller set. Yeah, that's interesting. LLB versus small language model, SLM. What is that? So
yeah,
we're at the top of the hour now. We've been live streaming for 57 minutes. So I got to end it up first. Johan, what country are you out of? I know it's obviously late. I can see the sunset starting to happen. Where are you at?
Yeah, I'm in the Netherlands. I'm in near the city of Amsterdam.
Okay. All right. Amsterdam. Yeah. Awesome. So I've been there one or two times.
Countryside.
Yep. Good. So we always do a barbecue report. Thanks to everybody listening to nearly the end here. So in Amsterdam, do you guys, you're obviously outside. So if you happen to go to youtube.com/vbarbecue, you will see Johan sitting outside in what looks like his backyard. Do you guys ever get to do it? No?
No, we decided this morning to rent a cabin on the countryside. So we just drove for 30 minutes towards the cabin, and there's a barbecue here. So tomorrow afternoon, it's going to be on, and I'm going to smoke some pork.
Nice. Very good. Very good. This just yesterday, my wife came out with some ribs, and so I smoked some ribs. But interestingly, I did smoke chicken a couple weeks ago, and I have decided that I do not like smoked chicken. I much prefer chicken on Kingsford charcoal or any kind of wood charcoal, because you get that crispy burnt, you like smoking does not burn the outside, right? You don't get that crispy charred, where I've decided that smoked chicken isn't my thing. Smoked pork is awesome. Barbecue smoked ribs are awesome. Smoked chicken, not a big fan. Rather do it on Kingsford. Tony Foster, I'm going to add you in here if I can get you to add.
Hey, there I am.
There we are. I don't know if it's starting to be summertime in Kansas. I'm just curious what you're experiencing.
It is. It is definitely summertime, and it is a great time for hamburgers and hot dogs and all of the traditional things that you put on grills. Hopefully this week I'll actually be doing some chicken breast. Last week I did a bunch of steaks, and those turned out fabulous.
I think we kind of overlook, because we're always talking about pork and chicken and steaks and, expensive meats and brining. And then, like sometimes just a good old hot dog on some charcoal, crisp it up a little bit, have it crack open, and then, get a good mustard and toast the buns. And that's all you need to do, right? Sometimes we just overthink everything, right? We're just give me a couple hot dogs and some potato salad and some lemonade. And, I'm good to go.
Absolutely. One of my favorite meals.
All right. Well, Johan van Amersfoort, good to have you on.
Almost.
Well, that's not bad for me, right? Like the fact that I called you Johan instead of Johan is a win for me. So there you go. That's right. Thanks for coming on the show. Great to have you. Good AI conversation. Good to see what people are doing in Europe. You guys are always leading the pack over there. Love your company. Love that you guys are the most populated vExperts out there. And thanks for doing it. And thanks for coming on the show.
Thanks for having me. Really was a blast. And again, I'm a big fan of the show.
Well, thanks a lot. It's always good to get the community together, talk. We'll be back here next week. Until then, go figure out where your VMUG is meeting, buy a VMUG Advantage, help what I call the VMware good space, or that's what I'm going to start calling it, the VMUG, your good place. What's the show on Netflix was Good Place or Good something or other with Ted Danson and I think it was called The Good Place, right? If you ever have seen The Good Place, go check out that show. That's my new thing for VMUG is it's your VMware good place. VMUG, your VMware good place. Go check it out. Say hello to people at VMUG. Until that, see you again next week. Tony, good to see you. Johan, thanks a lot. See you guys again next week.